Hi, and welcome to MyLab 2 for CDA 3201C Intro to Logic Design. So I've implemented the NAND gates with using two 7400 chips and two 7410 chips, which they are all NAND gates. And I've implemented the two Boolean expressions that I was required to. And I input those Boolean expressions into our 4-bit adder. So what I did was I put both the sum and both the C out Boolean expressions into input. For sum, I put for input A1 into the 4-bit adder, and then for the C out, I put it as the input for B1. I specifically set for the Boolean expressions, I set A in this switch for the first switch, B for the second switch, and C for the third switch. We are here to implement 4 plus 7. And if we implement this correctly, 4 plus 7 would give us, I believe, sum 4, or S4 would be light up, S3 would be not lit up, S2 and S1 would be lit up, as accounting for 1, 0, 1, 1, which is better known as the decimal number 11, and 7 plus 4 is equal to 11. In order to do that, I've connected the rest of the input switches to the corresponding switches right here. As in, I have A4, A3, and A2 to these switches. I have B4, B3, and B2 to these switches. And I also have C output into this switch right here. So in that case, I have my C out for this demonstration. I have my C out put at 0. I specifically, based on the truth table and also based on testing the NAND gates before I put the 4-bit adder, I've implemented which is 0, 1, 1, which means that only the C out expression from the NAND gates, the NAND network I should say, would only be true, meaning the sum from the NAND network, the sum output, the sum expression is not true. So we have A1 that is 0, not true. B1, which is true, which is 1. And how I did that, I implemented the switches over here, 0, 1, 1, meaning that the Boolean expression for C out is true and the Boolean expression for sum is not true. So we have our digits, the decimal digits that we're adding to each other, which are 4 and 7. 4 in binary is 0, 1, 0, 0, and 7 in binary is 0, 1, 1, 1. So what's nice is that we already have the last 0 for 4 already implemented, since we know that sum, the Boolean expression for sum, is not true based on this input right here. And we also have the last 1 in number 7, since we have that C out, the Boolean expression for C out is true because of this specific inputs of the NAND network. And we also have the NAND network plugged into these two LEDs right here. This one is for the sum Boolean expression, and this one is for the C out Boolean expression. So, as I will read, we have the first number, which is 4. So we have 0, 1, 0, and our last 0 is coming from the Boolean expression, which is not true, which is also 0. So we have 0, 1, 0, 0, plus we have our number 7 in binary, which is 0, 1, 1, and our next 1, our last 1 for the binary number of 7 is coming from the C out Boolean expression being true. And now I'll show you what we get once we turn the switch on. So let's turn the switch on, and we can ignore this. So what we get is true. We get that the Boolean expression for sum is false. It is not true. We get the Boolean expression for C out is true. So we have 0 and we have 1. And it's all based on this, which is 0, 1, 1. A is 0, B is 1, C is 1. Thus, in that case, the sum is 0, as in not true, and the C out Boolean expression is true, which is 1. So we have two numbers that we're adding together. So we have 0, 1, 0, 0, plus 0, 1, 1, 1, which equals 2, 1, 0, 1, 1. So it's great. It's nice, and we have connected our 1-bit adder to our 4-bit adder, and we are successful.